Good day, everyone. Our topic for now is about infinite sequence. This is Girlie De Soliva from BS Ed Math 3B. Infinite sequence. An infinite sequence is a function whose domain is the set of positive integers. S sub n is the value of this function for a given positive integer n. Sometimes we indicate S sub n just by writing the first few terms of the sequence S sub 1, S sub 2, S sub 3, and so on, S sub n. We shall consider only sequence where the values infinite sequence are real numbers. Examples. The infinite sequence of 1 over n is the sequence of 1, 1/2, 1/3, and so on, 1n. Next is the infinite sequence of 1 over 2 to the power of n is the sequence of 1/2, 1/4, 1/8, so on, and 1 over 2 to the power of n. Next example is the infinite sequence of n squared is the sequence of squares 1, 4, 9, 16, so on as n squared. And next is the infinite sequence of 2n is the sequence of positive even integers 2, 4, 6, 8, so on, 2n. The infinite sequence of 2n minus 1 is the sequence of positive odd integers 1, 3, 5, 7, and so on. Limit sequence. If S sub n is an infinite sequence and L is a number, then we say that limit S sub n as n approaches infinity is L if S sub n gets arbitrarily close to L as n increase without bound. If limit S of n as n approaches infinity is L, then we say that the sequence converge to L. If there is a number L such that S sub n converges to L, then we say that infinite sequence is convergent. When infinite sequence is not convergent, then we say that infinite sequence is divergent. Examples. Infinite sequence of 1 over n is convergent since limit of 1 over n as n approaches positive infinity is 0. Next is infinite sequence of n times the quantity of n plus 1 is divergent since limit n times the quantity of n plus 1 as n approaches positive infinity is infinity times the quantity of infinity plus 1 is infinity. Next is an infinite sequence of 2n is divergent since limit of 2n as n approaches positive infinity is 2 times infinity is infinity. Next is the infinite sequence of 5n plus 3 over 7n minus 4 is convergent since limit of 5n plus 3 over 7n minus 4 as n approaches infinity is limit of the quantity of 5n plus 3 times 1 over n over the quantity of 7n minus 4 times 1 over n as n approaches infinity. We solve this equation with the use of L'Hopital's rule. So we have the limit 5 plus 3 times 1 over n over 7 plus 4 times 1 over n as n approaches infinity. 5 plus 3 times 0, 7 minus 4 plus 0. The answer is 5 over 7. So that's why infinite sequence of 5n plus 3 over 7n minus 4 is convergent. Next is the infinite sequence of 8n over 3n minus 5 is convergent since limit of 8n over 3n minus 5 as n approaches infinity is 8n times 1 over n over 3, the quantity of 3n minus 5 times 1 over n. Using L'Hopital's rule, we proceed to next step, which is limit 8 over 3, 1 over n as n approaches infinity, 8 over 3 minus 0, the answer is 8 over 3. Next example is the infinite sequence of cosine 1 over n is convergent, since limit of cosine 1 over n as n approaches infinity is limit of cosine 0 as n approaches 8 is 1. So that's why it is convergent. And that would be all. Thank you and God bless everyone.